Welcome to the inaugural talk of DHS 2024. I'm really glad to be here back again to present some of the interesting learnings all through the last 2+ years in the whole field of generative AI. And I've been spending close to 15+ years in the industry, and I would like to share some of the real-world applications on something that is so cool, Agentic AI. So let's get started, but before that I would like to do a little bit of ice breaking. All of you pull out your phones, quickly scan this QR code, and we are going to have a quick power-packed 50-minute want you guys to travel along with me. So quickly scan this code, keep that active throughout, and you'll be able to take up some quizzes or surveys in the flow. And once you join that, hit that thumbs up button so we know how many of you have joined in. So if all of you are there, I'm going to get started with the first icebreaker. And if you have missed this QR code, you can go to menti.com. You can use this code and quickly join in. Go ahead, please. Fastest finger first. How many of you have really worked in the field of Gen AI, or you believe you are working in the field of Gen AI? Good. Let's keep the poll going. 69. Oh, we have well-informed audience. I see a good 100 people already, of which only 18 have responded. That's bad. Percentages are often misleading, right? Good. I think, but we see a fair split, 70-30. I hope that is the case, which means, guys, we are going to have a well-informed audience today. And let's go down the funnel and help me understand how many of you have got exposed to this framework called LangChain, one of the most popular frameworks in the open source community in building generative AI applications. Okay, again, we see that 70 slightly dipping to 60 of SS. Okay, I believe this is representative of the population out there. Let's go ahead quickly. Now, going down the funnel further, how many of you have built a retrieval-augmented generation system or an application? So RAG is one of the most popular, the cheapest ways to bring in Gen AI into your enterprises. So again, 60 is further dipping down to 53, 54, but still a fair 50-50 split we have. Now, here comes the billion-dollar question. How many of you have ever worked with AI agents, autonomous AI agents? You remember the 70-30 we started with? Good, this is what I was fairly expecting today. Thank you so much for taking this up. Now, the next 45 minutes plus, what we'll try to do is, we'll try to go ahead and talk through some of the most important topics around bringing that 30% of the audience who are aware of Agentic AI, and let's at least bring you guys up to speed. And what we'll get started with is think about this whole concept of large language models. The first 5 to 10 minutes, we'll think through LLMs, which we all have been fascinated with. And what are the different maturity levels of using a large language model? And it's very important for us to understand this stack. And then we will get spot on and take a head-on discussion with Agentic AI and why is it so powerful. Right? We have been hearing this term AI agents a lot, but what is that magical thing in there which is making it so awesome? Then I'll introduce you to various cognitive architectures, right? Which is going to help us in building multiple applications powered by these large language models. And I'm also going to introduce you to one of the interesting frameworks called LangGraph. And we are going to discuss about the different components of this LangGraph. And it is yet another interesting open source technology available for all of us. So once we realize the power of agents, how do we build one? So that's what is going to be the focus on this section. And then I'll show you how this different multi-agent, multi-actor workflow systems come together and how we even orchestrate all of this using LangGraphs. And we are going to look at a lot of mind-blowing demos today, and I'm really short on time. Let me try to introduce you to multiple flavors. I think all these notebooks and the ideas will also be shared with you. And some of the demos today are going to be, we'll look at how a React agent actually works. I'll introduce you to this framework, LangGraph, and even if there are absolute beginners out here, if you have some little background about graph theory, if you know a little bit of engineering mathematics, you'll be able to easily observe this, and this is a no-brainer at a point after we see the application angle. Then we are going to see how a developer and a tester are going to really come in front of us and do some real-world activities of developing a software for us. And first time, we are going to have an AI completely create a movie right in front of us. And we'll try our best to see what we can make. And you guys should also help me with some nice themes. And last but not the least, if time permits, I'll also introduce you to the world of agentic RAG, which is phenomenal. And I've also experienced a lot of these transformations in this field. So this is pretty much how this next few 40, 50 minutes is going to look like. First, the different levels of maturity of using a large language model. Of course, one can directly go ahead and prompt engineering, we can build chatbots, we can solve traditional natural language processing problems, and build something called a RAG system, and then we can even build an agentic RAG system. Let's take a second to reflect on each of these ideas. And technically, I see this as the growth or the maturity levels of moving from one level to the another in using large language. What is direct prompting? You directly go ahead and write something as a prompt to one of these large language models, to a system like that of ChatGPT or that of Gemini or that of Claude, behind which there is a large language model which is constantly powering that. And you go ahead and punch in some instructions. And that instructions which we give to the large language model bring some output for us. And now you can simply type a hi, you can just ask, write me an article, right? You can do whatever you want. That is direct prompting, which we all have definitely tried at least once in our life. But the next level of maturity is where we give meaningful inputs to these large language models with some interesting techniques like prompt engineering techniques, where we go ahead and explain what we want in a well-fashioned way. And sometimes you can even ask for something like a sentiment analysis, giving a tweet, and it's going to do that. That's called zero-shot prompting. And you can keep moving ahead with your specific examples on this is the format I want the example. You can give a few short prompts. You can even guide the LLM through the thinking process to get a best output. And there are multiple levels of maturity in this, like we can build a React agent, and all of these large language models, like we know, they don't read our mind, right? Like most of the humans, they don't as well. But we need to be that real, have that articulation, and that is what is the new field of prompt engineer as well. And I'm pretty sure that is one of the fields which is catching a big time. Even a lot of organizations have started hiring. And some of these techniques you see here is what that really plays a crucial role in for us to understand how to interact best with these large language models. Now, this is second level of maturity. You can gauge yourselves on where you stand if you got exposed to these areas. Now, I would say that third area is building a custom chatbot, where we go ahead to the next level. We know we cannot build a large language model just like that because it takes a lot of compute, a lot of money. But what's good here is we have these open source large language models like that of Llama, Falcon, Mistrals of the world. We also have these closed source large language models like that of the one coming from Claude or OpenAI or Google, Gemini, right? Where we can just guide these large language models by defining a role, by defining something like a system definition, like that of you are a storyteller. You are going to be an expert at solving mathematical problems. You wouldn't tell the answer, you would just guide the user through the process. You confine the boundary of how this giant large language models, which has got almost exposed to everything that we see on planet Earth, the digital media, is in there. Now it knows everything, but you're confining its boundary to say that you are a math mentor, or you are someone who is good at solving problems or puzzles, or you can even be someone who's an expert at giving advice on tech. So this is how we use the power of an LLM, but we don't build anything new. We just guide through prompts itself. We define a system prompt, we define roles, and we build a product out of it. That's what is the custom GPTs that even OpenAI popularly claims to be. There are a lot of custom GPTs available. If you're smart in writing prompts, you can even make your own products. This is also the next level of maturity in using an LLM, definitely less technically intensive. I see this to be, as a data scientist for almost 1.5 decades, I know that natural language processing is one of the hard problems. If you look at a decade ago, we used to really jump out of joy. I still remember the first time I built a sentiment analysis model, where even something like writing a sarcastic comment and making that model identify that was considered very difficult. Now, all of these problems are almost easy for these large language models, starting with spam detection to language detection, and you see the levels of maturity growing up. And machine translation, which was considered difficult, is also something which is happening live and streaming. We also saw some of these demos from these companies. So typically, these models are becoming more and more huge with their parametric memory. With the kind of data they have seen enough, they are easy at getting a task done the zero-shot way. Means you just give a question, you get an answer back. You don't even need to train. So now, as data scientists or as an analyst or someone who is just beginning the journey, we all have come to the same page by getting access to all these large language models, you see? Now, if you have never learned NLP as well, now you can go back and still understand the techniques, but now we have models which have excelled at that. Using this as the baseline, if these models can excel at humanly knowledge, we as humans who are going to be consumers of this can better use these models which are already having this baseline effect, right? So that's the thought process here. Now, the next level of maturity is building a RAG system. And this is what I call as the cheapest way to bring in your enterprise-specific domain data into these large language models and how they are able to even answer questions as if they have seen enough of your enterprise data. Perhaps your company is working on a path-breaking technology on which that data is not even let out to the world, but you want a battalion of scientists or people working on that to have a system to interact with this internal knowledge base. External GPT wouldn't know that, right? What do? You can take this pre-trained large language model, like that of the one powering ChatGPT, which is already trained on a massively powered data set, which is there on planet Earth. Now, all it does is, you have your internal knowledge base, you have some nice techniques to bring in that internal knowledge base, which could be PDFs to any forms of documents, and you throw it into something that is easily accessible for this large language model. Whenever there is a query coming from the user, we do two steps. We bring in the required documents that are relevant to answer this question. That is one step of retrieval. Then we try to give the retrieved documents to the large language model along with the question. Now you just ask it to answer the question based on the context provided, it's going to do wonders. That is what is retrieval, augmenting to the LLM's context, and then generation. That is RAG. So this is a 101 definition of what a RAG looks like, and which I really recommend all of you to get started with if you haven't. This is one of the easiest way to enter into the space of LLM in a very, very impactful way. In fact, we are building large-scale co-pilots just with RAG technologies, of course, topped with a lot of icing. Now, the last level of maturity, at least for now, as we stand in 2024, is Agentic AI. And this term, my God, the way it has been really gaining the traction is phenomenal. There is a good reason behind that, because these are systems which are really designed to behave in a very, very autonomous way, like how we humans perceive the environment, look at what is happening around us, think and act, instead of we directly jumping into a decision many times, right? So that is how these autonomous AI agents are programmed. Now think of this in solving a real-world problem. That is what we are going to do, right? Now, let me bring this very, very popular thing that is going on the internet. Did you come across this thing? People were mocking large language models out there. When you ask a question like how many R's are there in the word strawberry, sometimes even a basic task like counting numbers or simple mathematics, these LLMs lose. And we start complaining, right, as if we had a better system in the past. If you look at the capabilities of the system, it's really jaw-dropping, but certain basics it sometimes loses. And this is and sometimes it becomes so confident in saying something. You can even read up this real snap. How many R's are there? It says 2. Then are you 100% sure? It says, yes, I'm 100% sure there are 2 R's in strawberry. And would you bet $1 million on this? It keeps going, yes, I would. And this is from ChatGPT, by the way. And if you ask the same to Claude, even that does the same mistake. You know what? There's something called processing this data. We understand English, but a computer or a large language model has never seen English in its life. All it sees is a bunch of numbers, which are not even direct numbers of words. These are even partial words, something called tokens. A word like strawberry gets brutally broken into multiple parts, and it doesn't perceive a word as a word. And that's primarily the architectural reasons behind why it doesn't get the number of words in R like that. But we might think, right, why is it so fundamental? And we are trusting this to make enterprise-grade decisions by building a system like this? Now, for a second, a quick sneak peek. If we make an autonomous AI agent, just answer the same question, how many R's are there in the word strawberry? Here, just like how we humans would go about and counting these R's, as simple as that, right? It is made to think and act. with a simple thinking framework. And many times it gets it right in the first go, right? That there are 3 R's. So this is a very, very simple example of how a basic large language model's power is really beaten by an agentic AI system. Now, let me still go ahead and give you this picture. If I go to ChatGPT, and if I ask for a little article about autonomous AI agents, I send it to an LLM, or it could be an app, like that of all these we have access to. It goes ahead and writes an article. We all have seen it. It predicts token by token, and you see a nice article coming out. And that is called a zero-shot attempt, right? You asked for an article, it went ahead and kept writing the article, and it is done. Think of a real-world scenario. Do we work like that? No? We just go about, what do we do? What do we typically do to write an article like this? Draft? Revise? First step, what do you do? Plan? Search? Outlining? There is a process, right? Of course, right? There is, of course, a process. Now, if I ask the same question to an autonomous AI agent, it is absolutely going to do what we humans do. It's going to plan, it's going to research, it's going to make a first draft, it is going to keep on revising it till it gets the best draft. And this is human. This is how it has to be made. And if it is something that is writing the whole article on its own, it may not meet the expectations in the get-go, right? Until unless you write a great prompt, unlike this one that I've written here, right? Where you might have to say the style, you might have to tell the content, you might have to talk about the length, tone, so many things. Who's your audience? If you write a great prompt, you can still get it at one shot. But an autonomous AI agent typically would go ahead and do the same and to make an article. And this is a one-on-one way to think about how autonomous AI agents are different from the way we perceive large language models. Do not think of autonomous AI agents to be different. In the level of maturities we saw, you see AI agents are standing at the top of this LLM of maturity. It's still LLM, guys. That's the base on which the whole game revolves, right? Okay, very formally now, as the whole session is around agentic AI. Agents, autonomous AI agents, are systems which kind of mimic human behavior, like how we think, how we act, and how we perceive the environment. Now, let's break this down further, and you have to remember this important slide throughout the session, or the rest of the whole conference as in. First thing, it needs a brain to think. And what is that? A large language model. Fair enough? Then, how does it get the task done? It needs an arsenal in which a lot of weapons or tools are there, right? Now, even a Google search is easy for us. Now, even to build an article, we might go to Google, we might read up some blogs, we might go to Medium, we might do all that, Google Scholars perhaps, open books. All these are different acts we do. For an agent to do that, even it has to be made available with multiple tools. Sometimes it has to write a code, it has to execute, it has to get the result, it has to revise, all of that. So brain is there to think, and how to get the task done, you have tools. Now, before using the tools, you got to even plan that, right? You need to plan. For the thinking process, the LLM helps, but how to even plan this out, that's where multiple frameworks come into picture, right? And I'm going to deep dive in the next few slides. How to make an autonomous AI agent think. Now, the last but not the least, how does it even does all these things together? It has to have a short-term memory, isn't it? So that I started off with here, then I did this, now I ended up here. Now I got to revise my thing and go ahead all the way up. I might have sometimes replan all through my article. Like how we write, and we don't like, we have seen in movies, no, people crush paper and throw away, then start off afresh. Like the same style, even if an autonomous AI has to do, it needs a memory, short-term as well as a long-term memory, right? So short-term is for that particular task, long-term is sometimes even it has to remember things that you as a user instructed it a year ago, right? Now, I hope the base is set. All of you should be able to now perceive the idea of AI agents. Now let's get into what is an agentic application. Yes? An agentic application is any software system that we build which uses a large language model that really governs the whole process. It tells what has to happen. Every single decision point in the whole process happens with an LLM that serves as the brain, right? Now, let's think of what are the possible decisions that an LLM can make. It could be a decision to go to path A or path B. It could even be something like, which tool? I have so many tools that I am given access to. Now, for a task like this, should I use a tool A or a tool B? See, think about it, right? Even we humans sometimes get confused, right? Should I use Swiggy to order or Zomato to order, right? For the same restaurant you want to reach out, right? If an AI agent has to do it, it has to make clear-cut decisions, right? Now, think about this. It can even make something, and it can pull, even building a retrieval-augmented generation system, it might bring documents. But there might be 10 documents which have come, which is that 2 document or 1 document which helps in answering this question. So even there are multiple decisions like this, right? We can go on and discussing this. World is filled with the decision making. Every single thing in life is a decision making, right? If an AI agent has to do that, how? Now, let's informally think of this as an agent kind of runs this large language model in a for loop. It keeps using the LLM to think at every single step, and it's like running in a giant for loop, right? For loop is this programming paradigm. I hope we all know it. Now, if it has to really do that and achieve multiple things, we have to give it a thinking framework, a bunch of cognitive architectures. Now, these are some of the architectures which are very promising and popular today. Plan and execute, a multi-agent framework where multiple agents come together and get a task done. Multiple agents, of which one is making, the other one is critical about things. And there is an agent which can even think, act, observe, and go about doing this in a loop. And when the same framework, works across different architectures, right, that's what gives birth to multiple cognitive architectures here. And last but not the least, we even have a self-reflection, just like how we have these self-reflections during appraisals. We also have the same ceremony. When you do that with an AI agent, that becomes a self-ask. Now, these terms, if you fairly understand, that's okay. Now, I'm going to talk about an idea and we will see something in action. That's how we are going to go about now. A React framework is one of the most fundamental agents cognitive thinking. And it is nothing but, RE stands for reasoning, act. Reason and then act. Very simple, right? I asked for how many R's are there in strawberry. What is the basic reasoning here? How many? I got to count. Let me start counting and then let me answer. Instead of just answering something from my parametric memory as a large language model, why don't I do this? Very simple, right? A question is given, you think, you act, you observe, and if you think you have the respective evidence to answer the question, you stop the process there and answer and close the loop there. That is a simple React framework. Yes? Now, I think it's time for us to see the first demo of the day. Let me quickly bring up. I'm not a robot. Okay, so guys, let's see the first demo of the day. I believe it's still intact. Okay, so all we are going to do is install a bunch of packages, and I'm going to demonstrate all the different cognitive architectures using this LangChain as a framework, which is one of the most popular open source frameworks. Never have I ever seen a package like that of LangChain, which has been built on Python, which has gained so much of open source traction, and they are staying very close with the community, right, in how they actually build this whole system by taking inputs all from people like us, and we can also be contributors to that. And I'm doing the little hygiene aspects around this, and let me use one of the powerful models today, which is GPT-4 Turbo. Of course, it has its new brother, 4o, but you know what? The instruction following capability of GPT-4 Turbo is sometimes, right, very different from that of 4o. You might have to experiment in your application. Now, you see that first question. I asked us how many R's are there in strawberry. It said 3, great, but try this on 4o and you will understand what happens, right? So that was just a quick test to see if an LLM works that we invoked. Like I said, agent needs these 3 different aspects. It needs a tool, a memory, a planning. And let's take a little bit closer picture on the same definition we saw. It needs tools like that of calendar to calculator to code interpreter, which runs codes, searching, and planning all those different cognitive architectures I said, right? Reflection to self-critique to chain of thoughts, and a memory angle. Now, agent seamlessly does these tasks depending on the question that you're asked. Now, let me demonstrate a simple capability to use a Trevelly search API, which is nothing but searching the internet, right? And we are also going to create another tool, calculator, a simple calculator tool which is coming from LangChain has this beautiful submodularization, right, in which you have a lot of tools which you name it, you get it. right? All the developers, they integrate themselves with this. So before you build something new, you go and check out if something is available already with 1 or 2 lines of code. See, all I'm doing here is I'm taking an LLM match chain, I'm giving this base LLM, which is GPT here, and I make a tool calculator out of this, and I give a little instruction here. Even on this search tool, I said use this tool when you need to answer a question related to the current events or latest happenings or anything related to the user that is user's question. And here you use this question for anything related to math. We give this little instruction, right? This is the guide the agents use to decide, okay, should I use a tool here now? I'm running into a counting scenario, I'm running into a cube root scenario. So I need to use a tool like this. Because we know sometimes it misses these basics, right, which we think are very easy. But we should not expect all of that coming from an LLM. All it does is, it predicts the next best word. That's what an LLM actually tries to do. But when we expect mathematical tasks to reasoning to some of the complex tasks which we humans struggle, we need to have a sophisticated system to achieve that, right? So that's the whole idea. Now, I'm going to show you how these tools are coming together. And I initialize the next component. Now, quick recap, we got tools, we got the memory, we got the large language model. And this is how a React framework actually works. And I'm just initializing an agent by giving the tools to it, the large language model, and here is what I say, conversational React agent, right? So I just tell that the agent thinking framework should be something like that of think, act, and observe. And now, let's ask this question. How many R's are there in the word strawberry? Interestingly, it says 2 now. It's not stable, right? Keep saying 2, 3. Now, if we simply try to make an agent run the same, it tries to get that. You see that? There is a thinking here. Do I need to use a tool? No. But at least I am made to think step by step. I'm thinking now. I'm not answering, jumping and answering. For this, it doesn't need to use a string split or count or run a code or anything like that. Right? Perhaps it got it right by saying it is 3. Now, if you think about something like that of this, right? I ask a question like, which was the coldest day on 28th? Which was coldest, Hyderabad, Delhi, or even New York? If I ask a question like this, think of the steps. Potentially an agent, when it starts thinking, it knows that, okay, it has to go to the web. It has gone to the web, it has tried to pull something. Now it thinks that, do I need a tool? Yes, I need a tool because I haven't got all the information about New York as well in the first run. Now I do the second run, I get the New York City details. It keeps going like that. Now it asks, do I need a tool further? No, because I now have all the information. On 28th July, the coldest city among Hyderabad, Delhi, New York with the lowest temperature. Oh, surprise. And then we see this, that is 4 points. It even did that little math to say that it's 4.6 degrees is the difference. You see there, guys? A simple question. To answer this question, even we would do a Google search, 3 searches to get that answer. 1 click, an agent is made to think and answer, right? Similarly, if I ask a different question like, which city in Switzerland has got the lesser temperature than the winner? Now, you see that? I said the winner. Who is this winner? How do you know that? Because you just saw a demo, but how does this agent know? Memory, right? This is where the short-term memory helps. Now you see that it needs to do a web, and for this question, it is directly going and checking the cities of Switzerland on 28th July. I didn't even say 28th July here. I didn't even say anything about New York. So that is where the power of this memory comes, where on 28th July, a city in Switzerland recorded a lower temperature than New York, which was the winner, and that is 2.84 degrees further lower. So that is a simple example of how a React agent works. Fair enough? Yes? Okay. Time for us to come back and think through some of the interesting cognitive architectures. Right? Now that you guys are warmed up, you know how an agent is really doing wonders. Let's think through some of the design patterns or cognitive architectures here. The first thing here is, many times we see this, guys, many times we see this in our office setups, right? We have a big task, there is a supervisor or a manager or a lead, and there are multiple people working together as a team to get the task done. Imagine the same thing that you apply here. This is called a supervision workflow, where an agent working under a multiple agents work under a supervisor, and here the supervisor is nothing but an LLM which orchestrates the responses from different agents. Earlier, what you saw was a single agent trying to do the task of pulling, it was trying to crunch, it was trying to bring the answers. Now, if you think of an example like the agent 1 here is a researcher, which pulls your content from the internet. Agent 2 is a composer, or someone who's using technology like Beautiful Soup to pull this content from the internet of the content which the researcher has shortlisted. Now, you might wonder, why can't one agent do all this? Why do we need so many? There is an agent which is custom made to focus on one task. Your job is to only research. Think about us, right? If you are asked to do one versus if you are asked to do everything in a project, right? How different would be? That's how we have become a subject matter expert, right? Or we become master of all that, but right? That's how it happens. So now agent 3 is just a coder. Now this is a typical example. You can do whatever you want with this. You can do a research with the internet and you can build. And this is a very powerful supervisor agentic workflow. Now, if the team becomes so huge, if the teams are large in size, you have to build a hierarchical structure, isn't it? You don't need a single supervisor. You might need a giant guy who's smart at supervising multiple smart supervisors. And you have a research team, which indeed has a huge battalion of people and a document authoring team. So here, this is typically used when you have a complex system. And when you think of the number of workers for the agents increasing, it's always advisable to move from a single supervisor architecture to a multi-supervisor architecture. And this is an example of a hierarchical team. Very interesting idea. The plan and execution design pattern, right? This is so cool where you give a question, just like how we humans plan a task. We plan, then we generate a task list. How do I approach this problem? Then I use multiple tools or techniques and I get every single task done, and there are agents which are going to work in parallel in autonomous way. Keeps doing things on its own till it does the job done and when it's assigned, and it comes back and it thinks, right? Did I achieve it? Should I replan now, crushing the paper and throwing away, starting off afresh, or should I continue, right? So now when all this happens, finally, once it gets the answer response. This is a very, very popular framework, and this is where you see last 1.5 years, we have a lot of open source projects which are making wonders in this space. Typically, you think of React, it also did the same, right? When you want to think long, when you have a complex task, a single React agent may not help, right? That's where you need a cognitive architecture to plan and execute. So typically, when planning is expected to be long-term, you do this, and you can make smart choices, right, in this process by using a right LLM. You might want a powerful large language model for making the plan. For execution, even a small open source large language model, which is cost-effective, can be used, because everything is charged, right? Every transaction you do with the large language model. Let me tell you about this a simple example of this Hugging GPT, which is a very cool idea, right? Where to get a task done, like that of given a picture like this, and if you are asking how many animals or objects are there and can you even count, this is a simple task, but to a computer, it has to achieve this by first thinking, it's given to ChatGPT. Now ChatGPT and its friends from Hugging Face are going to solve this problem. And you see, there is this final answer where it is explaining that the herd of giraffes and zebras gazing the field, and it says, there are 5 detected objects. You can count for it. It's sometimes tricky for us. They are overlapping. And 99% confidence on how it gets a giraffe to a zebra, and it keeps going like that. And it also says, it first did a planning. Then it decided that it will use a scheduling mechanism in an order. And it decides for a task like that of object detection, for a task like that of coming up with accuracies or bounding boxes, different ones, it uses models like the Facebook ResNet or the GPT-2 image captioning, because it has to finally give the answer as well, right? So this is how it went about solving. Sounds simple, but how about something like this? You give a picture of a boy, right, on a scooter, and you're asking, I want an image of a girl reading a book, and her pose should exactly match that of this boy's pose, and also I want that particular answer, and you need to tell me a caption, and you need to even read it loud. How many tasks here? You see, first, it has to identify the pose, and there is a pose detection model. Then it has to create an image for the pose, which is the girl, and there is instruction that she has to read a book, and that is happening. Then it has to identify and caption that. So for that, there is an image captioning model needed. Then after that, it has to even generate a little caption to that, and further, finally, convert that caption into an audio. Multiple tools, multiple models are needed, guys. Multiple deep learning models are needed for this. You know what? Even if you do not know any of these models, you can still build these applications today. You don't need to be an expert at all this. That's where Hugging GPT as an example in plan and execute cognitive architecture, where multiple agents have come together. Everything is possible now, even if you are 100% non-techie, right? That's one thing on a side note. Let's now think of this framework, right? Critique and revise. In fact, I'm going to deep dive into some of these. When you see this in action, you'll really appreciate. The same thing like a plan and execute agent, but what if there is a little critic sitting there and saying, no, this is wrong. This is not right. Because sometimes when you say that an agent has not done something right, to an LLM, try this with an LLM, right? So you are wrong. It will go back and revise its answer. Have you seen this? When you regenerate, the same thing can happen, right? And you need to have a reliable mechanism in which you validate all the answers that are coming out, right? So that is where we have this critique and revise design pattern, where you can think of one agent which generates stuff, and you can think of another agent which reflects only on this generated content. And think of these two agents working together on any given task. Generator is getting a question from the user, it is doing all that planning, execution, whatever it wants. Finally, it gives a response to the reflector. Reflector critiques, it tells scores, you can even make it be very hard on all the criteria you have in mind, how your answer should look like, right? How your task should look like. Then it can go back as a feedback to the generator, and this can go on and on. And technically, it has to use a memory here, the generator to keep track of all the past feedback. A reflector should also progress ahead in its feedback, right? And we can lead to a lot of replanning and change. This is very practical. Recollect my first slide on AI agents, how an agent has to think, plan, act, revise, and keep doing. Now you are forcing that with a cognitive framework, and this is massive and very, very powerful, right? Best example is generating a book. You can even write a kid's book with that. You can write anything that you want with this. And I'm going to show you a very, very cool example on this, right? Now, think something very close to my heart, agentic RAG. Many of you might have built these RAG-based systems. This agentic RAG is mind-blowing, guys. The way it brings a lot of control to the answers we generate. In a sensitive enterprise setup, you can't afford to say there are 2 hours in a strawberry, right? People lose credibility. Nobody's going to ask that question though, but it is going to be a very domain-specific question, right? Now, you can't afford to say a wrong answer to an expert there whom you are going to make use of the GenAI product you have built. So that is where, I think if time permits, I will show you how we really built an agentic RAG system using some of these inspirations coming from these agentic patterns. But it's time for us now. I have only 18 minutes left. Let's think through this framework called LangGraph, because all that I'm going to do next in the next few minutes is only on LangGraph. It's an open source framework, again, coming from the strong backing from the LangChain community. And you can think of all the power that LangChain has, LangGraph also leverages. But if you think about this, it is going to help us in building these very robust multi-actor agentic framework systems where a lot of these challenges which we see in agents, sometimes they can go in infinite loops. Sometimes they may not behave as we want it to behave. It may keep redoing things in over and over and again. It might not sometimes stop. It might sometimes pre-conclude an answer, even though you instructed with a lot of prompts, right? That is where you need a framework which gives you a lot of control on the flow of their application. Because we have a large application where multiple decisions are happening. What if you have multiple agents, all of them are governed by a data structure like that of a graph, where different people or different agents are connected as nodes, and you see them working together, right? Let's see how does LangGraph achieve all this, and I'm going to quickly go from notebook to notebook, and we are going to first discover about the different LangGraph components. So I hope it's visible. All good? Zooming? Okay. So guys, going to start from the very scratch, right? So I'm going to quickly do some hygiene aspects here of installing some packages. And of course, you should always have an environment file to keep your secrets, API keys. And here, what I'm going to demonstrate is, first we are going to see how a LangGraph even looks like, right? Because if this notebook, we quickly cover this in a few minutes. And after that, when we go to our other architectures, you'll be able to appreciate how LangGraph is helping, yeah? So I think we have to do the hygiene aspects. This time I'm going to use the GPT-4o model. And while this loads, let's quickly see some of the pre-generated. I just asked a little haiku about AI conferences. Now, while the packages get installed, let us see this one. All we are going to do now is, we are going to build a simple graph like that of this, where I have a starting point, I have a single node, I have an edge between the two nodes, and I end it. Simple graph. Two nodes, like how we see on LinkedIn, two people connected, there is a connection, so there is an edge between the two people. Like that, there is this popular graph data structure which we can use, right? So let's check if the LLM is intact. All I'm going to do now is, I'm going to define two simple functions, right? Pay attention. You have two simple functions, you simply get an input, all it does is, it just appends the string first function to that. Then when I send that output, right, send another thing to another function which is input to, I get an output appended with second function. Now all I'm going to do is, from LangGraph, I'm going to import this graph and I create a graph object. Now to this graph object, I'm just going to take this little function we have here, function 1, and I'm going to make it a node. Mind you, a node in a LangGraph can be a simple function, it can be a large language model, it can be an agent, it can be anything. Now, all I'm doing is, I'm simply adding these nodes to the graph object I instantiated. I add this little function 1, then a function 2. So you have this node 1 and node 2. Now I'm simply setting an entry point, which is the node 1. The graph should enter at node 1. And I add an edge between node 1 and 2. And I finish with node 2. Finally, I compile the graph. Boom, the graph is ready, guys. Two simple functions. I first did the mapping. Then I connected them. I compile it. It becomes a graph. Now, you might wonder what's happening here. I've built this graph. I can go ahead and get multiple tasks done with. This is a very one-on-one level of building a LangGraph. If I want to visualize my graph, this is how it looks like. I see the same thing, node 1, node 2 connected. My graph looks like this. Let's say I send the input I move from, right, to this graph. You see that? I move from first function to second function. So technically, whatever I've dropped here on the top has gone to the first function, which has appended this I move from first function, then it has added to second function from the second node and has given. Now it has happened at one shot, right? What if I want to see the happenings as and when it is happening, right? It's getting executed on the graph. I use this little function where a graph can even stream its output. You see, this is the intermediate step here, right? The output from the first node is, I am moving from first function. Now this exactly goes as an input to the node 2, which says I am moving from first function, and what was the job of the node 2? To just append to second function, right? That is what has happened. You see, I dropped on the top. Now, typically, a little formal definition of building a graph would be, you first build the large language model, instantiate, which is the LLM, let's say a GPT. You tell all the tools it wants. You create something called a graph state, and I'm going to explain that in a second. And you define multiple nodes that you want, like how we did. We set an entry point, we set an exit point, we compile the graph, it is ready. These are the typical steps, right? 6 steps in building a LangGraph. Now, I'm going to do something interesting. I'm going to quickly build something called a sentiment analysis. And there are 2 nodes here. The first one is just a sentiment analysis function. It is just going to take that input from the user. It is going to get a prompt like it's an expert at sentiment analysis. It's going to give the sentiment. And the second function is going to take that sentiment and make it in uppercase, right? All we are doing is the same thing. We create the sentiment analysis function, we create the first node, convert to the second node. Let's visualize it, right? Because that's what we love doing. We now have a sentiment analysis node, then it converts to upper. 2 simple functions. If I put a little sentiment like that, the movie was so nice, I walked out of the hall in 2 minutes. Highly sarcastic, right? When I used to ask this question to sentiment analysis models a decade ago, trust me, it's a real story. I used to explain that sarcasm is very hard. It's sarcastic, right? It used to go by the words. Movie was so nice, positive sentiment, classified, job done. But here, it's a sarcastic negative statement, right? When I ask something like, wish the movie was nice, but it was extraordinary. See that? So this is also a mixed, it might get run into a mixed sentiment, but it is super positive sentiment here, right? Let's see what happens when I stream this step by step. And boom, you have the question going, that's a positive sentiment. On converting to upper, the output is positive. This is the under the hood happening. But what if I want to build something little interesting, right? Let's say you have this graph and I want to have something like a conveyor belt where each node can read something from the conveyor belt and can put something back. That's like a common repository for all these nodes to access anything from, right? So that is an example of how something like a state which is accessible like a big repository for the entire graph where every node can do some transaction with it. Think of that. This is what helps the whole agentic workflow to be governed by something common. Everybody has a common frame of reference, and that is a state. I'm going to now quickly define something like a little state here. It's a simple class which is inherited from type dig. It is simply going to contain a key value pair, and I already say that, okay, there can be a state variable called user review, sentiment, and what is the sentiment in upper. If I want to just achieve the same task that I did above, but this time I am simply going to add a little graph state as well. You see here, I add a graph state to that. Earlier one was a simple plain graph. Now I added a graph state to it. Everything remains the same, right? But I just added a little state as well to it. Now when I do that, right, we can see this in action. Where I run this sentiment analysis, I ran the same tweet. Sentiment analysis node is in action. I get the output that the current state of the graph is, this is the state of the graph. When it started, it was empty. Now it got the sentiment. After running that, finally it made it to an upper. This is the revised state. So we can keep track of the state at every single point of time. Now we can do the same thing again and again. Now think about it, right? This is a simple graph. What if I had to add a condition? I want to check some condition. I want to analyze the tweet when it is negative, right? Shall we do that? Let's quickly build that same thing. But this time, what I'm going to do is I'm going to create one more node for review analysis. And this will take the input from the previous steps. If the tweet is negative, it is going to simply do that. It's simply going to do an analysis, right? So I'm going to quickly build a workflow. I'll show you the graph, so you will see that in action. Boom, there you go. Here is the final graph ready. Start, do a sentiment analysis. You see that little dotted edge here? What I've done here is, I have added a conditional edge here. Conditional edge, it will check for a condition. If it is negative only, then do it. If it is positive, just end, right? We don't want to analyze a positive sentiment. Now let's say I give a very, very confusing statement like, the movie was nice, that I walked out of the hall in 1 minute. Then I came back within 5 minutes and then slept off. Woke up and saw 2 back-to-back shows, enjoyed with pain. Pakka fanboy moment, right? I don't know how many of you have done this. I have done it. Yes. Now we run this, right? Look at this beauty here. So you see, the sentiment is mixed. LLM itself can't manage this guy. It says it is mixed. He is confused, right? But still, we asked you to analyze this guy's emotion at this moment, right? It says there is an immediate disinterest, then there is inconsistent engagement, sleep-inducing factor, ambiguous whether he enjoys it or not. These are the different reasons why I justify this mixed sentiment. How cool this is, guys, instead of just saying it's a mixed sentiment. So this is an example of a condition being checked. If I run a positive one, right, then this is a real tweet coming from IMDb, right? We can keep reading this later, but now it's time for me to jump into the next idea in the interest of time. Let me quickly show you a real developer and a tester, and this is a real-world example, right, where you will see, let me go on full screen, so you can see this architecture. In the meantime, I'll just install these packages. Give me a second. Yeah, so very interesting phenomenon, right? A dev always thinks the code built is right, but a tester doesn't care. He always wants to find a fault. Now, when you think of a company setup like that of this, in a typical sequential scenario, there are different teams, right? In a waterfall model, people design, then they develop code, then they test, and they document. And if you think of an open source framework like that of this chat dev, it's a very, very powerful framework where you create multiple roles and you kind of chain all of them together. And they interact in a scenario where they develop a whole product for the company, right? Now, what I'm going to do is, I'm going to extract these dudes here, a programmer, a reviewer, a tester. Focus on this side, right? Where we'll create a developer and a tester, right? And we'll try to see if, okay. I think I got to get the env file, which is missing. Quickly. Okay, there you go. Okay, it's working. Cool. Now, let's jump into the real story. This is the critic revise pattern we saw. A quick recap. Tester, generator will develop the code. Tester will critique about the code and it will find faults. Let us do this in action. Like the same style, I'm going to define multiple nodes. I'm going to define an interesting node this time, which is Python REPL tool, because we need to write codes, right? So I create a developer node, give a prompt. You are good at developing codes, Python codes, and we give a lot of nice instructions to it to make a good code. And we tell a tester, your job is to test, find faults. And the tester will write test cases, guys. Like how an automated tester or a manual tester will write these test cases. It will write the test cases. And we define a graph state. We tell the maximum number of reflections these iterations can do is also a variable, and it keeps track of the conversation history and a reflection count. Now when we try to run this together, right, I built the graph like I did already. I have this entry point, exit point, the conditional node set, right, where it will go. This is the little graph. It looks so cute and little, but look at the power of this. We are going to now finally put a memory as well. Let's play Flames, right? So very nostalgic game, right? So I'm giving this task of write a Python code for Flames game and give a complete executable file to test with 2 names as input. And this is the instruction that is going to the developer. And it is, boom, it has started thinking that I just write a frame. First, the developer explains the Flame game to us, right? Friends, love, affection, marriage, enemy. Then it uses this tool, Python, and it tries to basically write the whole code, okay? Good. And it finally creates an executable file by giving the instructions. Now that goes to the tester. This dude, what he has done is, he has understood it's a Flames game, cool. Now let me use unit test. I will write nice functions to test this. Look at the kind of test cases it is written. For a friend, for a love, for affection, for different cases. Tom and Jerry marriage. Okay, but it's still testing, no? It should test cases. You see, cool thing. It has finally checked for all this, and it has got this results. And the developer has got a critique, and now he's going to now revise this game, and the revised code is coming back to the tester. Finally, he tests it, and at last, right? I've set this reflections to 1, and it ends here. Yeah, and this is that little code that you see here. We can even quickly play. Any suggestions from the audience? Arun. Okay. Let me try my wife's name. Thank God. Okay. So it's marriage. I don't think I'm running into any troubles. Now, likewise, guys, this is a simple demonstration. I'm really running short of time. So this is a dev test 2, guys. You saw the power. Develop any code that you want. You don't need to be a developer now, right, anymore. You can really test because an agent itself is critiquing for it. So this, you can build even complex systems like that of any real-world game, right? I'm going to get into a very, very important and a cool scenario, which I never want to miss today. And this is, we are going to have this real story, screenplay, and action created by agents. And I'm going to definitely finish in 5 minutes, organize this. Let's see. This is the first attempt where we see, and this is how the design pattern looks like, right? Where there is a start. We give a concept. You guys can give a movie concept, right? Let us create a story for that. And now let's invite the 2 legendary directors from South India, Rajmouli and Shankar, to create screenplay for that. Yes? And this time, we as humans are going to evaluate the screenplay and we are going to give an input, which is a winner among the 2 screenplays. And human input, human in the loop happens, and then a full movie storyboard gets created. You guys know what is a storyboard? It's a sketch of before they even go out and direct. It's pre-production work where they do a workshop with the actors by creating the scenes. And this is sometimes going to take even multiple months to a year altogether, right? So let's quickly see this in action. And I'm going to bring in the config file in the meantime. And this is, we were really surprised by the way this was working, right? I really hope that we also get to experience that now. Okay, so while these things install, I'm going to quickly show you the idea of creating a concept creator has to be an agent. We need a screenplay agent, right? Screenplay writer we need. We need a storyboard creator. And we need someone to generate these images for us, right? So there, I use this model called DALL-E 3. So DALL-E 3 is this image generation model who is going to take, and who will do the research? We need a web search. So for that, there is a tool called Reveille. I'm quickly building the whole graph, and you see, there are prompts like this written. For creating a storyboard, there is a perfect instruction given. And for creating a concept, there is and here we are going to do an ad concept, right? You can even do a movie concept. We are going to make a quick 10-second ad, write a screenplay. First screenplay is from Rajmouli, and this is his prompt. And this is the second node, which is going to write in Shankar's style. And finally, we have an evaluator node, which will do the evaluation, and finally, the storyboard creation. Boom, the graph is computed. And 1 more minute left. Let's see this in action. And this time, let's have a concept like a time travel machine is our product. And I'm going to make someone from Niman's conference from Bangalore travel to the Taj Mahal. Let's imagine if this is the concept. What happens, right? The concept here is time journey from Niman to Taj. And this is the first concept that is written by the concept creator. And you see there is an opening scene at the convention center at Bangalore. We see the time travel booth. And our story is ready and our directors have even written their screenplay. You see, this is the screenplay by Rajamouli. Good, delivered on time. We also have Shankar. Why am I using these words, Shankar Rajamouli? Because they are known for some style, right? So here we see the whole screenplay written in that style. Which one do you want? Quickly, 1 or 2? I know, Indian 2 effect. Okay. Sorry for any fans out here. Okay, good. Now, the storyboard creation is in action, and I'm also excited to see what's going to happen next. You see, this is the whole scene by scene, which has been observed. You see, these are the characters. This is the scene 1. This is the middle scene. Okay, there you have. The first scene, right? And this is our first scene of the movie where this is the convention center at Bangalore. This is Nimhan's, by the way, guys. And you see, this is Nimhan's convention center. Okay, with the attendees on all the sides, everyone is getting into the road, crowd is filled with eyes, mysterious booths, all that is there. Then we see a time travel booth there, something like you see here. This dude touches it. He wants to travel to Taj Mahal. Now the third scene is, he gets lost in this, he goes into the time machine and he's time traveling. And there we see Ravi is the dude, right, who's been the lab rat today. And these characters, everything is generated by AI, right? It's still going on and on. Because why? Because it is trying to make, the agent here is trying to take scene by scene, analyze, and it is going to use these different components of tools. Here it is DALI. And the screenplay here acts as the prompt, right? And there are these instructions given for it to use the characters intact and follow the storyline. And you see, he has gone to time travel when Taj Mahal was constructed. Right? Taj Mahal is under construction. Awesome, right? He's seeing the Taj fully. See, they're building the basement after building the front. Now you see, finally, guys, we see this guy meet Shah Jahan. Oh, meet Shah Jahan. Shah Jahan is being there, and finally, that is how, I think this is typically the last scene. We are done. And finally, he came back, I guess. He's back to Nimhan's Convention Center. I think he deserves this for this lab experiment. So he came back after meeting Taj Mahal and seeing all of it in construction. So guys, that is all I could do to power pack all the Agentic AI in action for you.